Welcome to the Crazy Hat Chemist. So another video in bonding and molecular structures. Bam! So today we're talking about phosphorus pentachloride, molecular geometry, and oh, so much more. So phosphorus pentachloride, what's the formula? It's a binary non-metal compound with a prefix naming phosphorus pentachloride. There it is, PCl5. You're going to look on your periodic table to determine the number of valence electrons for phosphorus and for chlorine. So 5 valence electrons for phosphorus, 7 for chlorine. There are 5 chlorines. You're going to multiply, then add these numbers up. You're going to get 40 total electrons of valence electrons. Then you're going to divide this by 2, and then you're going to get 20 pairs of electrons. You're going to look at the phosphorus and the chlorine, figure out which one is the least electronegative based on its location on the periodic table, and that element is going to go smack in the middle. That is phosphorus. Phosphorus is the least electronegative of the 2 elements. Now, the other elements, those are the chlorines, they're going to surround the phosphorus. But before we do that, we're going to take a look at where phosphorus is located on the periodic table. Is phosphorus in period 1 or 2? Oh, no, it's not. It's in period 3. And what can happen with period 3? They can be hypervalent. That means that they can exceed the octet rule. So, bam, this is why we are going to place the 5 chlorines all around. If it's in period 3 or greater, that's period 3, 4, 5, 6, or 7, they can be hypervalent and exceed the octet rule, and that's why a chlorine is not attached to another chlorine in this case, being that you would only have 4 chlorines around the phosphorus and then the 5th one attached to one of the other chlorines. That doesn't work, that doesn't happen, never seen it. Okay, now what we're going to do is we're going to place these electrons around the phosphorus and in between the chlorine, forming a single or a sigma bond. That's what we've done right there. Okay, now any electrons available after that, we're going to place them on the outside elements just like that. Okay, now what are we going to do? We're going to check the octet rule for chlorine, because chlorine does follow the octet rule. Okay, and that is the case for every single chlorine around the phosphorus. Now, what we need to do is we need to check the phosphorus. Again, this has already been mentioned in placing the chlorines around the phosphorus, but it is exceeding the octet rule. Just to verify that, that's what we've done. Now what we're going to do is we're going to clean this Lewis dot structure up by drawing lines for single or sigma bonds, and then this is the structure of which you should see right there. So you have a single phosphorus with 5 singly bonded chlorines with 3 sets of lone pairs of electrons on each chlorine. Are there any lone pairs on the phosphorus? No. Okay. So this is an AX5-like structure. So the A is the phosphorus in the middle. The 5 is the 5 chlorines for that X there. So that's AX5. How many bonding pairs? How many non-bonding pairs on the central atom? So how many bonding pairs? 5. How many non-bonding pairs? 0. So that's what we get right there. Now, based on this, we're going to get the shape, the name of the shape of this, and it is trigonal bipyramidal. Okay, I've showed you this before, but just to make sure here, I'm going to show it to you again because this is a cool structure. I love this one. It is trigonal bipyramidal. You should see the trigonal structure in the middle, and you should see that there's a pyramid on the top and a pyramid on the bottom. So let's keep on going here. The bond angles here are obvious as well. So in that pyramidal structure, we have that trigonal in the center. That is a planar structure of a trigonal, and those are bond angles of 120. And then we have from the pole to the equator, that would be 90 degrees. Okay, and so we're going to count this and look at our hybridization. That's S, P1, P2, P3, D. So this is sp3d hybridized. Okay, now the last thing is the polarity of this. Okay, so is this polar or non-polar? So you're going to look at the symmetry of this molecule. Are all the green things, which are chlorines in this case, are they all the same or are they different? They are most certainly all the same. So that means, does it have bond polarity by itself? Yes, it does. So the phosphorus bond, the polarity is going from the phosphorus to the chlorine, from the phosphorus to the chlorine, but they are all equivalent. And so that makes this symmetrical. And that is the next video, and I'm wearing a 50-gallon hat. If you like that video, if you like the hat, give me a thumbs up. Subscribe to my YouTube channel, partner, and have a delightful day. Hee-haw.